Hi all, welcome to my ozone technology course. This will be session 21A, which will be on swimming pool parameters. This session will discuss the following topics: turnover, superchlorination, spas, therapeutic pools, jacuzzis, and a small aspect of the introduction of ozone in swimming pools. With respect to turnover, we have already had a slight mention on it, what exactly it is, as with superchlorination, but I am going through this again just to emphasize the importance of these two terms. As I have discussed this turnover in the previous sessions, I am revisiting it. As an analogy, if you put a spoonful of sugar in a cup of tea, for the sugar to dissolve homogeneously, you must stir the tea. Likewise, the injection of chlorine or any biocide is done outside the pool in the circulation pipe. This biocide must be circulated throughout the pool, hence for the turnover. The definition of turnover, where one turnover is equal to the total volume of pool going through the pump. If the pump, say, pumps 600 liters per minute or 36,000 liters per hour, and the pool volume is 100,000 liters, then the pool turnover is 3 times. That is about 100,000 divided by 36. The minimum turnover limit is mandated by regulations, and it is critical for the pool to be properly disinfected. We are discussing the formation of chloramines and the significance of superchlorination here. Chlorine gas is a yellowish and it has a very characteristic pungent smell. Chloramine has a smell that is often misinterpreted as chlorine in the swimming pool surrounds. If the swimming pool is properly chlorinated and there are no chloramines, there should be no smell of chlorine in the surrounds. Chloramine comes in the family of organochlorides or organochlorines, some of which have been used as chemical weapons. They all cause mutation of the cell RNA and DNA and cause cancer. So the maximum limit of chloramine content in the swimming pools are mandated. As you know, chloramine is formed because of the reaction of our body fluids, sweat, etc., which contains lots of protein matter reacting with the chlorine to form the chloramines. As the formation of chloramines is reversible by simply increasing the chlorination above the threshold level of 10 ppm, which is the same as superchlorination, it can be removed, or in other words, the chloramines can be reversed. This subject has been discussed in the fundamental session. While this graph may be a bit complicated, I will try to explain to you the gist of the meaning of this graph. The breakpoint chlorination is about 7.6. At a concentration of about 5.8 ppm. In other words, we have to pump in at least 7.6 milligrams per liter of chlorine to be able to obtain a product about 5.8 milligrams of residual chlorine. What will happen is, at this juncture, when the chlorine is above this point, our injection is above that point, about 7.6 milligrams per liter. Most of the chloramines will be dissociated to form dichloramines and nitrogen gas, and the free residual chlorine will proportionally increase. But though we need only 5.8 ppm and an injection of 7.6, we try to be more liberal to ensure that the whole equilibrium is shifted towards the right. We make the chlorine residual to be about 10 ppm. So we have to add 10 mil per liter of chlorine to give that 10 ppm residual. This way we are able to remove the chloramines, and once the chloramines are destroyed and the free chlorine is dropped to the satisfactory 1 ppm, the pool can just be used. Besides the swimming pool, we also have these therapeutic pools and spas, hot spas and jacuzzis. Hot spas and therapeutic pools operate at a significant higher water temperature, as high as 35 degrees centigrade or slightly more. At that temperature, chlorine as a biocide is very unstable and dissipates rapidly, leaving the pool with insufficient biocide. So in order to compensate that, we may have to add a higher chlorine level. We have to operate the pool, the spa, at a higher chlorine content. The other disadvantage at high temperature is the bacteria are more active at the higher temperature, and such reduced biocidal activity can cause infections to patients using the therapeutic pools and spas. So possibility of infection through spas are very high. So it is very important that we maintain the high chlorine dosage, which obviously is not going to be extremely comfortable. There is another chemical called bromine that can be used in hot spas or hot water. Bromine is next step down to chlorine. Chlorine is a gas at atmosphere temperature. Bromine is a liquid. It's heavier, and so even though it is less soluble, it's sufficiently soluble to be used as a biocide. And it is more stable and less volatile at the temperatures in hot spas and therapeutic pools. The discussion on swimming pools will not be complete unless we discuss the significance of therapeutic pools. Therapeutic pools are just like swimming pools, but generally designed for patients who require physiotherapy. These pools are almost always located indoors in the hospital surrounds for patients who are rehabilitating after the trauma of surgical intervention. Many of these patients are weak, immunosuppressed, and therefore the swimming pool water or therapeutic pool water must be more thoroughly disinfected. Chlorination has been normally used, but ozonation has been widely introduced and preferred. If there was some company which has their application expertise, and if the owners are aware of the superiority of ozonation. Ozonation ensures totally clean pool and gives the added protection to the vulnerable patient. The spas, hot tubs and jacuzzis, all these are one and the same. They are termed differently in different countries. They all have hot water circulating in a small tub or pool. The only difference is that in the spas and jacuzzis, air is also pumped at high pressure to create the tingling and pleasurable sensation when impinged through the several small nozzles covering the whole back of the person. Whether it is a jacuzzi or spa, hot tub or hydrotherapy pool, all use warm or to hot water, a temperature at which bacteria and pathogens thrive well. As I did so for therapeutic pools, this water also must be disinfected properly. Generally, bromine alone will not be sufficient because once the bromine gets used up to form bromide, we have to replace it with more bromine, and bromine is very expensive, and bromide accumulation is also toxic. In the case of chlorine, the chlorine after usage becomes a chloride, and chlorides are just salt water which has got less effect on our health system. The ideal system is therefore the ozone-bromine combination. The bromine gets used up to form inactive bromide. This inactive bromide reacts with ozone to active bromine, and it continues as a disinfectant. So this continues to recycle. In other words, the bromine gets used to bromide, becomes bromine again because of ozone, and so on. And therefore, you may not need the addition of further bromine other than supplementing it when it is lost through sprays and generally sprays. And if there's a filter, through filters. Bromination and hydrazation, as I did just explained, that they are both part of the halogen family, just like chlorine, and behave very similarly, except in intensity. Chlorine is the most powerful, followed by bromine and less iodine. I have not mentioned fluorine because fluorine is so very powerful and reactive that it is hardly of any commercial use unless it is being used for very high fluent reactions through manufacture or so. Bromine is denser but a liquid in normal temperature and pressure, while chlorine is a gas. Iodine is still further denser and is a solid at atmospheric pressure and temperature. Bromine therefore is less volatile than chlorine and more stable in hot water like spas and jacuzzis and hot tubs. but once as they are used up, forming bromides and iodides, they might be replaced. Further, bromides and iodides are toxic at high concentrations, particularly so with bromides. Chlorine is the best disinfectant, followed by bromine and then iodine. Iodine is least corrosive and used as antiseptic application like tincture of iodine. Both bromine and iodine are expensive, just to be used for once only application. But when we use with ozone, the inactive bromides or iodides formed can be reconverted to active bromine and iodine. Bromine is more commonly used in spas, jacuzzis and hot tubs rather than iodine. The reason why iodine is not used because it tends to stain the tubs. Dosage of ozone is critical when it is used with bromine because excess of using ozone may cause the bromides to form. In other words, the bromide forms bromine with ozone, but this bromine may react further with ozone to form bromides. And these bromides are toxic. Therefore, the concentration limit of bromides is mandated by council regulations. I will now introduce the ozone for swimming pools. But before I do so, I would like to narrate an experience I had when I first installed ozone in a pool in Taj Hotel or Taj Coromandel in Chennai. This hotel is one of the famous hotels, and it was used by Her Majesty Queen Elizabeth II on a visit to Chennai in India. I met with the Taj environmental manager, Taj Group environmental manager of the hotel, and offered to install a new ozone system for their worst pools and cooling towers. He, having studied in USA in environmental science, suggested that the cooling tower and swimming pools in Taj Coromandel was the worst, that being the oldest in Chennai or in India. I inspected the very old cooling towers and pools. I looked at the cooling towers very carefully, and I informed the manager that while I can ozonate the cooling tower, there might be some problems which it is necessary for me to explain. Once I install ozone into the cooling tower, the ozone will start working to descale the pipes, removing all the scales which would have been a good protection of the tiny holes through corrosion that would have formed for the last 20 years of operation. And the holes may show up by leaks within 3 months of operation of the ozone system. He was shocked that I rejected his offer to put ozonation for the cooling towers because of the possibility of ozone being blamed for leaks. I offered to install an ozone system in the swimming pool, free on trial for 3 months, provided on satisfaction after the 3 months on agreed operational parameters, he would purchase the system. The parameters were drastically reduced chlorine costs and less maintenance and clear pathogen-free pool. He agreed. The system was installed. Within 2 weeks of my return to Australia, after I completed the installation and commissioning, I was recalled for a serious problem. The pool had progressively become milky, causing them to turn off the ozone system and back to chlorination. I returned to India, inspected the pool, and recommended then restart and continue the ozone system, ensuring the pool will clear itself as the water is filtered, and then they backwash the filter weekly until the pool becomes clear. They did so, and the problem was resolved, and the pool was very clear that we could see the head or tail of a rupee coin at the floor of a 3-meter deep pool, and we got paid. The company became the #1 in pool ozone installation in India. The question, why did the pool become milky and why did it resolve? The answer is that the pool was very old, the pipes were terribly scaled up, the ozone broke down the organic layer of the scales, which keep up the scales together. And when the organic layer was stripped off, the scales didn't have any binding to keep itself on and deposited straight into the pool. Over time, when the scaling was totally removed, the pool became clear. This is a typical diagram of a commercial ozonated pool. This is a pool. Now, if you notice, there are 2 inlet lines where the water goes into the pool. There will be a skimmer line, which is a drain on the top of the surface of the side of the pool, which sucks out any water containing all the particles, etc. And you also have another suction line at the bottom of the pool that sucks the water onto the joints of the skimmer box, and together the water is sucked into the pump. The pump then pumps the water through the valve, through the filter, and through valve again, and it splits into 2 lots, 2 sections. One section goes straight to the heater and heat it up, and the hot water goes into the pool. The other section goes through the valve again, control valve, through the venturi. Now, this is where ozone is pumped in. This is the oxygen concentrator. That means the air is sucked in through the oxygen concentrator and produces oxygen. So the oxygen fed into the ozone generator gives you a higher concentration of ozone. And the ozone comes through the Teflon tubing, and obviously any water, moisture, dust, etc. is filtered off, and the filtered oxygen, ozone, will go through into the venturi where it is sucked, and venturi mixes the ozone with the water and goes into the contact chamber. Contact chamber is where the ozone has got an opportunity of totally dissolving and any undissolved gas is taken away through the valve and goes for destruction. The ozonated water goes through the cold water line and back into the pool. I would prefer not to use the ozone water inlet very close to the water outlet, because there is a possibility of the water just shunting in, go back to the pump without circulating. I would normally put in 2 or 3 or 4 jets and allow the water to go through the jets. Most likely this is a diagrammatic figure, and that's why it is just showing that it is being pumped at the bottom of the pool. This diagram is a simpler diagram of the flow diagram of an ozonated pool, and as I did mention, this will be the swimming pool. There are several jets coming in from the mixing tank or contact chamber. So the ozonated water is fed through the jets into the pool. The skimmer will collect the floating debris as well as the flow of the water coming from the inlet out through the outlet, and that will collect the water, goes back through the pump into the filter, and if necessary the pool heater, and back to the pool. The one aspect of the line is split for injection of ozone. So there is a separate ozonation pump for it, which gives an added pressure and flow, so that the venturi that is will be able to suck the ozone at a faster rate, and this is the ozone generator. So the ozonated water will go back into this mixing tank and proceed along to the pool. Again, this part is where you can remove any undissolved ozone and oxygen, and you can vent it through, and probably through a destruction system. The ozonation pump is optional, because what I might do is to take a sample of water from here, which is high pressure or more. Just it comes out where it distributes high pressure and feeds into the venturi, then comes back just before the filter. I would say here. Here is where the branch will be, and it filters here and goes back into the pump after the filter. The reason why the ozone gas should not be, and water and ozone gas should not be before the filter, because then the gas bubbles will be retained here and destroy the filter, the sand filter, and mix it up. So venturi injected gas must be injected after the filter. The water can be taken for the injury for the venturi before the injection end, but as soon as the water comes out, because there will be a higher pressure here which will push the water into the venturi and goes back into the lower pressure point before it goes into the system. What I pointed out would not have a heater here because we don't want the ozone to be destroyed or broken up by the heater. So if I had to use this pool for heating without using an ozonation pump, I will probably have a separate line which has got a heater which will heat up the pool through a separate line. This is the venturi section where the ozone feed comes through the venturi. The main line, most high pressure water goes through there. A small portion is diverted into the venturi. It must have significant pressure so as to drag the ozone into the system, and it joins up here to form ozonated water. That is, here, the ozonated water. We also need to have, at this point, a valve to prevent a suck back into the ozone generator in case the pump stops and water tends to go pumped into the ozone generator and destroying the electronics. We have come to the end of session 21A of this ozone technology course. Thank you for having the patience to listen to this presentation. I hope I haven't confused you, particularly in the last slide. But if you look at the diagram very carefully, you would be able to follow the flow of the water as well as injection of the ozone carefully. If this is the first session you watched, please refer to sessions 1 and 2. That will be the list of topics in subsequent sessions and the details, and session 3 to 20. Please click the like and subscribe buttons, and you will be notified of each session as it is uploaded. Thank you and have a very good day.